to get a chance to talk a little bit about solar energy and specifically the status, some of the challenges that we're facing today, and also the promise, because I think there's a lot of very positive things to be optimistic about. This presentation will be on our NREL website, and that's www.nrel.gov, and it's at the end of the presentation as well, and you'll have access to it. I've got a lot of information, but what I wanted to do is just make a few key points on each of the slides that I'll show, and then from that point, hopefully that will stir some questions, and be happy to enter into a dialogue regarding some of the ideas and insights that I provide. So without further ado, let me go ahead and change to the first slide, and I will advance it to slide number 2. There, thank you. I can see that now. Back up one, please. So the first slide, which is essentially a map of the world, and it just the point that I want to make there is renewable energy in general is about a $280 billion business worldwide, globally, and to date we've invested all the countries of the world have invested more than $1 trillion in various technology and technology deployment, and there is a wide group of countries that participate. Okay, go to the next slide. What you see is, even though that this technology is beginning to get adopted in the marketplace, it's still a fairly small fraction of the overall energy mix. Actually, this slide shows that 16.7% of our energy consumption globally is from renewable energy, but about half of that, 8.5% of the global energy mix, is actually traditional biomass. And that, of course, is a form of renewables that is not as sustainable as we would like it to be, and so we're making some transitions to have more modern biomass opportunities. The modern renewables, excluding that piece, is 8.2%, which is still fairly significant. But when you recognize that the largest part of that is hydro, then the smaller portion of that, of course, is wind, solar, geothermal, and the other power generation technologies. If I move on to the next slide, one of the things that this slide shows is over the last 5 years, the compound annual growth rate of all these various renewable energy technologies has been phenomenal. It's been in the 20 to 35%, and in the case of solar, it was almost 60%. And the yellow bars in this particular graphic are what was the growth rate in the last year. So what you see is all the technologies are growing fairly rapidly, but solar actually is outpacing most of the others, and it is the technology that has the most amount of international investment. If I go to the next slide, the PV market in particular is growing fairly rapidly, and the expectation is that it will continue to grow. This is a expectation of total worldwide capacity out through the end of this calendar year, and you can see it's still on a fairly rapid trajectory. The next slide is annual growth PV demand that we expect out through the year 2014, and this is when asking a number of experts, stakeholders, people in the marketplace. This is the consensus that you get, is that there's going to be continued growth out for the next couple of years, and you see that much of that growth is in developing economies around the globe, and lesser so in Europe and in the OECD countries. If I go to the next slide, this is the picture as it looks in the United States, and there you can see that there's still a fairly significant amount of growth in the U.S. Most of that is, as I'll show in a couple of slides later, a direct result of what's going on in utility scale deployment, and a lot of that's being driven by the recovery and stimulus investments, as well as public policy. If you go to the next slide, this shows a map of the U.S., and really this is what's driving much of that deployment in the U.S., and that is essentially regional or state by state portfolio standards, we call them here, but essentially they're mandates. They're mandates that a certain mix of our energy generation for the future from the utility companies needs to come from renewable energy of some kind, and in some cases they have solar carve-outs. And as a consequence of these renewable portfolio standards, which each state does a little differently, in our state of Colorado, we have a 30% mandate by 2020. Then that's driving the deployment that you see. If you go to the next slide, what you see is that in addition to the state by states, there's the Recovery Act work. So the American Reinvestment and Recovery Act actually did have a fairly significant effect and influence on the amount of deployment. And the solid lines on the left-hand side of the chart is the deployment of both photovoltaics and concentrating solar power projects in the U.S. And the dotted lines are those that are under construction, or those that will come online as a direct result of those other investments. If I go to the next slide, what you see is the value of solar installations. And in the U.S., we have over $11 billion of value if you take the system price times the number of megawatts that have been deployed. Globally, that's over $100 billion. So you can see that there's quite a bit of activity just in the solar PV area alone. And of course, that translates to jobs here in this country. Based on some of the statistics that we gather from the various people who are deploying technology, we see we have well over 100,000, approaching 120,000 new jobs as a direct result of the technology that's being pursued. If you go to the next slide, what you see is that system prices continue to decline, and in fact, they've dropped dramatically in the last couple of years. And I'll get into the reasons for that here in a minute. But you can see this steady reduction in the cost and the price of the technology over the past decade and a half. And that's very exciting because it does suggest that there are some real opportunities here, and we expect that there will be greater opportunities in the future. Now, one of the things that the little bars on the far right-hand side of this chart is what our analysts expect that we're going to get to, and those numbers are very competitive, as I'll show here in a minute. If you go to the next slide, this is data that we actually take from our many projects that are being deployed in the U.S. Again, as part of the stimulus spending, the 1603 is a federal act in the U.S. that allows there to be essentially a 30% reduction in the cost of the initial cost of a system to incentivize the deployment. And these are the costs that were put into the applications for that program. And so they're fairly significant and I think important surrogates for what the actual cost of these systems are. And you can begin to see that the downtrend is quite dramatic. If you go to the next slide, what again is another one of the features of what's going on in the marketplace is that what you see is over the past few years there has become we have grown into a manufacturing capacity expansion that has outstripped the demand. And so the yellow bars in this graphic is what the solar cell capacity is in this country, or I'm sorry, in the world, and the green bars are the demand globally. And so all of a sudden we have more supply than we have demand, and that's what's giving rise in a large respect to these rapidly declining prices. If you go to the next slide, what you see is one of the major components of a solar cell is polysilicon, and polysilicon has always been a fairly significant and important part of the value chain because that's the starting material from which you build these solar cells and modules and systems. And so when the cost was, back in the late 2000s, you were seeing that the cost was up like $140 a kilogram, and that was extremely challenging in terms of getting costs down for the technology. Today, those costs are around $20 a kilogram. So that sevenfold decrease in the cost of polysilicon, major ingredient for the cost of a solar cell, is in fact a testament to the fact that there's been a big expansion. We've now included a bunch of new facilities that are generating that material for solar cell production, and these are structural changes, and over time the market will equilibrate. But it does in fact influence how one of the challenges these dynamics. One more slide, if you would. Let's slide. Yeah, there you go. Thank you. Let's see, is that the right one? I am on slide number 15. Is that the one you're on? Okay, I can't see very clearly. I think that's correct. All right, 15. This particular slide shows PV manufacturers' margins over the last couple of years, and this is not a good thing for business in the sense that the operating or the gross margins have declined. If you go to the next slide, this is the operating margins, and these are the margins that once you've paid all the bills and made the investments that your investors really look at, and some of these have gone negative over the last year and a half, and this is quite disturbing to the people in the marketplace, because obviously you can't lose money at this rate and make a sustainable business. These are actually very much the challenges that the industry faces, and it has to do with lots of things: the slow recovery, the way in which national programs, subsidies, and incentives have progressed over time, and ultimately these are continuing to be a challenge. Or investment. This is just in balance. A couple of years, there's been big investments from the national programs in various countries. And these are, I think, important in terms of helping with the technology, but unfortunately, they're not sustainable. It's hard to continue to maintain that kind of government support. And so, over the course of the last year, in 2012, those investments have diminished, and you see a very much of a slowdown in terms of investments for continued deployment. In that picture, if you go to slide number 18, is the one I'm on, also is true in the U.S. The picture in the U.S. very similar to the picture globally, and what you see is that the U.S. made their stimulus investments in 2011, and that's the big blue bar in this particular graphic. If you go to the next slide, this is again the last of the bad news slides, which is essentially the top 34 solar companies have an index that these are the publicly traded ones on the global marketplace, the so-called Guggenheim Solar ETF, or the TAN index, and you can see that from a shareholder investment perspective, these are in fact not doing well relative to the other technologies in the marketplace. I think these are all challenges that the market faces. And in fact, as I will make the case next, why I think it's important that there be a national program in investments going forward to help get us past what some of these challenges are that are a result of many factors, but none the least of which is the global recession that many countries are now facing. If I go to the next slide, this is the beginning of the kind of the good news story. Here is a chart that we use in the U.S., and it talks about the levelized cost of energy and how it is actually declining over time. And our expectation through the Sunshot goal that the White House and President Obama and Secretary Chu have championed is one that has, I think, a great opportunity to make solar competitive with fossil fuels without subsidies. And specifically, we are looking at a goal of about $1 a watt for a system by the year 2020. I think it's a goal that's achievable, and it's a goal that I think has a great amount of opportunity embedded in it as we go forward. The next slide, which is intended to show that there is tremendous solar resource around the country, around the globe. a number of recent reports. I was a member of the IPCC, the Intergovernmental Panel on Climate Change, special report on renewable energy. I also participated in the Global Energy Assessment. These are major efforts by the world's best scientists in the area, and they all say the same thing, and that there is tremendous opportunity for technology to make a difference, and in most regions of the world. If you go to the next slide, some resource assessments that we've done at our laboratory, and on the same scale, you can see the relative value of the darker shade or the greater amount of solar insolation. I point out Germany only because Germany right now is the number one country in the world in deployment of photovoltaic technology, and they have found it to be cost effective relative to their energy prices. And if Germany can do it, certainly the rest of the world has, I think, great opportunity as well. And so we applaud their leadership, but there's an opportunity for everyone to do much better. If you look at what are the residential costs along the vertical axis in the next slide, if you go to that one, what you see is the cost of energy along the bottom axis. What you see is the amount of sunshine that any one country would get, and then the blue line is when you get to grid parity in terms of the cost of energy. So in 2009, the cost of photovoltaics was such that only Hawaii had a cost of energy versus how much sun they got break point that allowed them to be above the levelized cost of energy grid parity line. If you then kind of move that forward going out through 2020, what you'll find all the way to go ahead and click all the way out to 2020, what you'll see is as more and more countries become their solar technology becomes competitive with the conventional cost of energy in their region as the cost of energy comes down. And so by 2020, we expect that most of the world would be cost effective for solar technologies if we meet the price points that we've talked about in this Sunshot Initiative. So we're very excited by what I think is a tremendous opportunity going forward. Let me just say a few words about technology, and then I'll open the floor up for some questions. If you look at the solar cell, just the anatomy, this is a cartoon of a solar cell. The features are a bit exaggerated here, so for illustrative purposes. But what you see is, it's a fairly simple device. Sunlight comes into this major, layer of converter material, and what you get out is electricity and no moving parts. It's very elegant. You have a lot of process steps. It looks a lot like an integrated circuit or something that you would do in a semiconductor technology. But we've learned a lot in the course of the last 30 years. I've been in the business at least 3 decades, and what I find is that it's really exciting about what we've learned and what still needs to happen. We're now looking at all different kinds of materials. So if you look at the periodic chart, all different kinds of materials that can be used for converting sunlight to electricity. These materials have certain characteristics to them. In this case, many of them are polycrystalline, we call it, and they have grain boundaries and some things. But what we want to do is really reduce the resistance to the conversion process, and that is something that we're researching in the universities and research institutions around the world. The way you get the electricity out of the particular device is an important piece, and that has a couple of features to it. One is you don't want to block the sunlight when it hits the top of the surface, so we're looking at techniques to get rid of that. And we're also looking at how can we better use the energy in the solar spectrum. You might know that the solar spectrum is made up of lots of wavelengths. The shorter wavelengths are higher energy, the longer wavelengths are lower energy, and the way you convert those is all part of the physics process. But we're working very, very diligently on all aspects of how you make those technologies better going forward. This is a slide that we like to use because it talks about all of the champion cell results or the best results that we found in the laboratory since photovoltaics, really the modern era of photovoltaics started, which was in the late 70s. And what you see is technology continues to improve across all the various technologies. There's lots of different pathways, lots of different materials. Many are very exciting in terms of research results. But ultimately, what you want to do is take these research results and put them in the marketplace. This little inset in the graphic, if you go to the next slide, or next click rather, go ahead and click all the next. Yeah, there we go. One more. I'm sorry, I'm a little ahead of you. Go ahead, one more, and the last one. This is the slide of the champion cells, and if you click once more, there you go. Thank you. What we see here is the gray bars are the theoretical efficiencies on what these technologies can produce. The bottom yellow bars are the ones that are actually the commercial products of today. The orange bars in the middle are what the best results are in the marketplace. And so what you see is the opportunity that we have from where we are today in commercial product, like in that very top cell, that concentrating photovoltaic cell. We are at 31% in the commercial marketplace, 43% in the laboratory, and 63% is actually the opportunity that we have theoretically. What that suggests is that there's a lot of room for improvement. And that's really what the research agenda is about in most of our laboratories around the world. If you go to the next slide, it shows that this is the Sunshot Initiative that we've launched in the U.S. I would offer that if we can achieve the results that we've set as goals in this particular program, this would make photovoltaics competitive in any market in the world. Certainly is true of any market in the U.S., the regional markets, but also we believe anywhere in the world. If you go to the next slide, we have a lot of collaborations with many institutions around the world. This happens to be one that comes from our Fraunhofer colleagues in Germany, and they show that even the conventional technology that makes up almost 90% of the world's marketplace, which is crystalline silicon technology, has a lot of room for improvement. So the bars on the left are the ones where the technology kind of is today. These are commercial cells that are in the 18% sort of range. But you can actually get that same technology all the way to the right-hand side, which will be efficiencies of like 24%. These are the components of the various colors there, the components of the various losses. And you can see the losses can be reduced by doing some techniques that we can deploy in the marketplace fairly rapidly. The real issue is cost, and how are we going to move the cost? If you go to the next slide, what we have is projections of what those might look like. Today, silicon technology is on the order of $1.20 a watt by the analysis that we do at our laboratory. And what we find that is if you put some of those techniques that are deployed or that are suggested by our Fraunhofer colleagues, then you could get down to on the order of 60 cents a watt for these modules. And what you'll find is that when you get to that point, you can deploy these technologies almost anywhere in the world. And we have an analysis that we're looking at the value chain and supply chain, both in the U.S. and in China, and they're very, very similar. And my argument would be that you could do that almost anywhere in the world. So these prices and these costs are available to anyone who really wants to put the effort into it. If you go to the next slide, it really is universal in terms of the same sorts of reductions can be made in the so-called thin film technologies. In this case, it's cadmium telluride, but it could be any technology going forward. If you go to the next slide, and I'm almost done here, and I'll open it up for some questions. What you see is that there's an opportunity to do what we call multijunction cells, or taking advantage of the various wavelengths of the solar spectrum by putting in different layers. Now, this makes the cell a lot more complicated. As a consequence, it makes it more expensive. But these cells have been already demonstrated, and we're well over 40% now in terms of their conversion efficiency, but the costs are still high. So if you go to the next slide, the way you get around those costs is you go to concentrators, and essentially you concentrate the sunlight with very inexpensive optical elements like a Fresnel lens, a secondary concentrator. That allows you to use very, very little photovoltaic material and less and a lot more of the inexpensive optical material, and that allows you to get very cost effective as well. The last technology I'll talk about is organic photovoltaics, and if you have a cell phone or a mobile device, you will note that the technologies that we're talking about in this slide are the ones that you find on your cell phone. These are the coatings that are there, and what you find is that the touch screens have organic LEDs, which is just the reverse of a solar cell, coatings on the back of these. this technology is exciting for a lot of reasons, one of which is it's nanostructured material, very, very elegant in terms of science, but at the same time, it can offer the opportunity to be able to do large area solar conversions and be able to print this like you print newspaper. And it makes it a very, very exciting technology because it can be relatively inexpensive and can be of great value in the marketplace. And then the last slide that I have on this one is essentially, and you can also do the spectrum splitting. So you can put multiple layers. And again, this is now more advanced research, but it's also an opportunity, I think, that the photovoltaic community offers going forward, and that the sky is the limit in how much we can extract in terms of photovoltaic technology. So let me stop by just offering a couple of conclusions. One is the global solar deployment continues to move at a rapid rate. Again, the market conditions are such that there's been a lot of progress and a lot of people have gotten in. The present industry, which is like $250 billion, 250 plus billion, is still, I think, in challenging, difficult fiscal times because of a variety of issues related to energy, related to the economies of the world, and there's some issues there that I think need some attention. The third point that I'll make is that there needs to be continued investment. With continued investment in the R&D in particular, what we'll find is that we'll get past these challenges. We'll be able to get the cost of these technologies in a range that will be competitive with conventional fuels without subsidies. And I think that's kind of what everybody's goal is. And there's a lot of market players that can be part of moving those costs down the curve. And more importantly, I think there's an opportunity here for a significant amount of economic development as these technologies mature and as these industries begin to have a bigger impact in the world. So I want to offer the conclusion that these are really, despite the fact that it looks pretty gloomy at times, these are exciting times for the renewable energy industry, in particular the photovoltaic industry, because I think, again, tremendous opportunity in the development and the innovation space. And we already have an industry that has begun to mature and enter the marketplace, and we really do need to have, I think, a consolidated effort. International collaboration and cooperation is really important in this arena, but it's exciting, I think, for us, those of us in the technology field, because we see so much progress being made. Okay, so I'll stop there and offer the opportunity for anyone that has questions or clarification items that I can answer. Thank you.
All right, thank you very much, Dan. Do we have any questions in the audience? We've got some coming in from online, but if someone here in the audience has one, we can start there. All right, our first online question is, sources of energy aren't the only issue. Storage is also a concern. Do you have any comments about solar storage capabilities or technologies?
Sure, that's a very astute question and a very important one, and that really has to do with long-term, what do we expect out of our solar and otherwise renewable energy generation technologies? Storage, I think, ultimately will be a very large and important component of the future energy mix. If we are ever going to optimize the opportunity that renewable energies provide, we need to have storage. In the short term, when our overall generating capacity globally is less than a percent for all of these modern renewable energy technologies, storage isn't as much of an issue. It is obviously if you want to have a standalone application, in which case you need to have some way of generating energy when your resource is not there, either wind or solar or whatever. So I think it's important that we also have a parallel effort investing in all types of solar, both for large utility systems, for smaller commercial and residential systems and standalone systems. The technologies that are out there today are not sufficient for what we need. So where we can get some voltage support with large batteries, and the battery technology is progressing. It's really not yet cost effective. I mean, the best form of energy storage today is pump storage, so hydro pump storage. So if you have the opportunity to pump water uphill when you have energy, and then extract that energy when you don't have the renewable resource, that's a real nice mix of a storage capability through hydro and a renewable source that only is able to work when you have the renewable resource. There are other technologies as well that I think are in the mix. Certainly compressed air and CAES, we call it, compressed air energy storage. And there's a number of mechanical sorts of things where you might do flywheels and some other things. These technologies, I think, need to be supported. At present, they are not yet cost effective for the marketplace. But I certainly agree with the notion that we need to have a fairly concerted effort. And I think in the next 10 years or 20 years, as the technologies mature, then the storage will become a lot more important than it is today at the initial stages.
All right, thank you. Any questions from the audience? All right.
Hi, thank you for joining us. My name's Kate. I'm from the Seattle area, and I'm with an organization called Sustain Us. I was having a debate with a friend recently who works for actually renewable energy and solar industry, and he was saying we already do have the technology. It could be market effective. What we need is to make sure that the externalities of coal are just properly taken into the price of those energies. So if we were including the cost of these externalities, renewable energy like solar, like wind, would actually be cheaper than the coal option. Is this true? Can we use incentives like a carbon taxation policy to incentivize more solar? And if so, is it then market value acceptable?
So that, again, a very astute question, and that certainly will be very stimulating discussions around our social environments. I think there's a good point to be made here. We have an energy system, and certainly this is the one in the developed the OECD countries, where it was 100 years ago that we decided kind of what the ground rules for how we would deploy our energy. And as a consequence of that, what we have is an energy system that has served our purposes and needs well for the last 100 years. It doesn't really serve our purposes and needs well for the next 100 years. And one of the ground rules was that we really didn't pay attention to these so-called externalities. We didn't really think about the costs or the implications of price volatility, about the access to to limited supplies, about things such as emissions of all kinds, including carbon, and all of those things which we now lump into this broad category of externalities. And certainly today's system does not value those externalities in the cost that we pay for energy. As a consequence of that, if you want to have a new technology come in and now compete side by side, there's certainly a valid argument to be made. Well, let's decide what the attributes of the future energy system should look like. And if those attributes are things that we can all agree on, then let's price the cost of achieving those attributes in the cost of the energy that we produce. And there I would say you have to take all the incumbent technologies and reprice them on the basis of the new attributes that you want to achieve. And that's a long-winded way of essentially saying that, yes, by all means, if there were a price on the emissions of carbon, then clearly the technologies that don't emit carbon would get a benefit from that sort of a policy. As it turns out, the present system does not employ that policy except on essentially a very fragmented sort of way in certain regions of the world, but not all regions of the world. That is a discussion and a dialogue that needs to occur. The second question would be, so what should that price be? Well, there's plenty of room for debate and discussion about how much to price carbon. and whether or not that's a free market, let the market decide, or whether that's a mandated thing. All of those things to say make this very complicated, and we understand that. And so as those discussions of public policy take place, I think what we really need to be doing is moving the technology down the price curve so that it becomes the killer app, if you will. It becomes so cost effective that it doesn't matter if you put a price on carbon or not, it's always going to be the technology of choice. Until we all agree on what the attributes of our future energy system needs to look like, that really is the only way that I see to make progress, that we've made progress over the course of the last 3 decades. Clearly, it's a discussion that needs to be had, and clearly it's something that will influence the cost, the relative cost of these energy systems. And already in niche markets, you find that these technologies are cost effective. I live in a large commercial building. In fact, I'm in the building right now that is on an annual basis net zero energy. It's totally supplied by the generation of photovoltaics. So we have 2.5 megawatts of energy that we generate on this campus, in this building, and it more than compensates for all the energy we use on an annual basis in this building. Now, the sun doesn't always shine, so I have a two-way meter with the utility, so I'm getting energy from the utility on when the sun doesn't shine, and I'm exporting energy back into the utility when the sun does shine. So one can argue that in some cases we can make the case that we already have a demonstration that we can make. And by the way, if you take how much we paid per square foot in this building, including the photovoltaics, we built this building and all of the costs associated with it for less than what you would build a conventional building for. So one can argue that in some cases we're already there. The real challenge is how do we do this in a much broader way so that everyone can take advantage of these opportunities.
Thank you for your presentation. I'm Mr. Tabbouch Mohammed, NGO president in Algeria. Please, how about shale gas in U.S. energy strategy comparatively to the solar energy? Thank you.
Yes, that's a great question, and it's a question that we address in every conversation that we have over the last 2 years. Certainly, there has been a tremendous amount of, I would call it innovation and new opportunities that have come from the discovery of new ways of extracting shale gas, and for that matter, even some tight oil. And we have these both hydraulic fracturing as well as horizontal drilling technologies that have allowed us to more cost effectively extract these fossil fuels out of various regions of the world. So as people always ask me, so is that a threat to renewable energy? Is that a technology that's going to slow the progress of renewable energy? And my answer to that is it doesn't have to. It's certainly possible that it could, and we're looking at a variety of things. But one of the things that I've tried to encourage is the fact that we know what the attributes are of our future energy system. And that future energy system at some point says that there is a very, very minimal carbon emissions. Getting from where we are today to where we need to be is really the challenge. And we're going to need all the technologies to help in moving us in an effective and efficient transition. It is actually a very good thing that we have natural gas. Most of the natural gas that's being deployed today is actually displacing coal. It doesn't really displace renewable energy. As I showed in the charts that I have, renewable energy continues to advance, and I think it will continue to advance even in the face of very cheap and inexpensive and accessible natural gas. Now, the caution that I have is that long term, even natural gas emits carbon, and it's about half of what coal emits. So at some point, we will have to start thinking about how do we extract the carbon from a natural gas deployment strategy. And so there's several studies. There's a study at MIT that was just done on natural gas and specifically its role long term in carbon abatement. the conclusions that they draw is that it's good to take advantage of it in the short term, because I think it helps us with reducing carbon emissions because of the nature of how it displaces coal. But long term, we need to be thinking about how can we use natural gas as a bridge to a new future that will be more energy sustainable than a technology that has many of the attendant emissions that we're trying to combat in today's environment. So I think it really requires that we look at our picture, at our energy picture long term. And we look at it from the perspective of what's the best transition strategy to get to an endpoint that we need to get to. And I'm confident that there is a way in which natural gas and renewable energy and some of the other technologies can have synergy and coexist in the new environment. But I caution against thinking that natural gas is the answer to our energy needs and then give up on all the other alternative technologies.
All right. One more question? All right, we have time for one final question here.
Hi, I'm Nikki DeLuca, a student representative from the American Chemical Society. I'm wondering if your lab has worked on how to incorporate these new renewable energies into our current infrastructure, or if you foresee transitioning to a new kind of infrastructure.
Another great question. I think these all have to do with how do we move more aggressively, more quickly into a new energy economy, if you will, that has a different set of attributes to it. We think about infrastructure a lot. Well, here's a couple of points on infrastructure. Our infrastructure today is a huge investment. So nobody wants to make a wholesale change very quickly because it's going to cost a lot of money. And we're going to spend literally $20 trillion globally on new infrastructure just because we've got to replace the existing infrastructure. The question is, what will we do? What will the new infrastructure look like? And the transition is really the issue here. And how quickly can you make that transition? Is there a new approach that might be more favorable than the approach that, again, was developed and designed more than 100 years ago? And my argument would be certainly in the electricity sector, and you have to look at electricity and transport perhaps separately. But in the electricity infrastructure, I believe there is a new model. The model that we've grown up with in the U.S. is big power plants and big wires that connect these power plants, and then you get electricity that way. I think the new model is one that's got a distributed sort of characteristic to it, and so that you have local generation, much as I mentioned about the building that we have here. We're a generator of electricity on our campus, so we're a distributed resource. I think over time that will be a model that looks a lot more like the internet than central computing. And I think the energy system should look the same way going forward in the future. It is a matter of transition. It is a matter of how do you make this, the old system begin to evolve into a new system. And that's going to be more incremental. There, I think, is an important on how you shape a new system with a new vision. One of the new facilities that we have at our laboratory is called the Energy Systems Integration Facility. And it contemplates this new business model of a much more distributed resources, where you not only have variable load, which the industry is very good at accommodating the variable demand of the consumer on electricity, but also one that has variable generation, so that when you have renewable resources that in fact are variable in their generation, that these two can be compatible with one another. And now you have a system that's got intelligence to it, and you match the load with the generation in very unique ways, and it begins to look a lot like an IT infrastructure as opposed to an electricity infrastructure of the past century. So I think there is a huge opportunity here to move toward a whole new way of thinking about energy. And that goes also true for transport, where we have a whole new different set of options, vehicles to grid that allows you to do electrification of your fuel source in a way that now you're using electricity rather than liquid transportation fuels, gives you more options, gives you more flexibility. It's all now part of integration of this overall energy infrastructure into the ways in which we approach mobility, comfort, and heat, and those things that really we rely on to create businesses and improve our economy. So it's a great question. It's one that we think a lot about, and we're very much in the middle of that, and encourage all of the young professionals who are thinking about careers to move into these areas, because I think it is the wave of the future. Thank you very much for the question.
All right. Thank you again, Jack. Sorry for that great closure there. Right now, we're going to finish up with this session, and at 5:30, we've got our next thing going on over at our NASA Hyperwall. So we invite you to join us over there, where we'll be raffling off one of our very popular photo books featuring images from NASA. So as I said at the beginning, this U.S. Center is a cooperative effort that's led by the State Department from various U.S. agencies. We've heard from the Department of Energy. Now we're going to move up to space and talk about NASA. Then at 6 o'clock, we'll come back here to the U.S. Center looking at efforts working with local governments from a few representatives from various agencies. So again, thank you, and another greeting back to Colorado. So we'll wrap up here. Thank you very much.